Hello everyone, welcome back in our class today. My name is Victor Odigomore here, and we are about to go into something else that different from what we've been doing. We've had so many classes now in circle and its properties. Yes, we have been able to look at so many things that has to do with the circle and its properties. Far behind, we were looking at chord, chord, you know, and then chord properties, and we're able to look at so many problems and so many questions along that line, as well. And then we have been able to do a lot of problems. Please, if you have not been able to check out on those classes, you do that, because it's going to be of great benefit if you check out on those classes. And of course, if you subscribe to the channel, you'll be able to have access to those classes. All right, we want to go into trigonometry. Yes, we want to go into trigonometry, and we are going to be going from a trigonometry 1. And the first thing I want to do in trigonometry, you know, like I promised us in our classes here, we we try to bring you to a point in which you understand the detail. That is, it's not just this is not an entertainment, that. So we try to make you to understand, like those of you who are following us in our classes in circle theorem, we started seeing that we discussed those theorems one by one. And when we are done doing those theorems, about 7 of them we did, and then the ones we did, okay, and then we started looking at some problems as well. This is how we are going to go. All right. I want to, I want us to see how we can be able to derive the sine rule from this acute triangle. The derivation of the sine rule from an acute triangle. After this, the next will be the derivation of cosine rule from an acute, from an acute triangle. Derivation of sine rule and derivation of cosine rule. These two things we are going to look at both of them immediately, because these two derivations is going to help us to delve into simplification of problems in angles of elevation in preparation for us to go into bearing and distances. When you have a problem triangle and you want to solve it, it might need you to use Pythagoras theorem, it might need you to use SOHCAHTOA, as the case may be, sine rule or cosine rule, and then, yes, to solve it if that problem needs those approach. All right, so without taking our time, I've done a lot of explanation. Please check out the previous classes we did. All right, it will help you to follow what you're doing now. How can we be able to derive? It's very, very simple and direct. There's no time to waste on that. The derivation of sine rule from an acute triangle in few minutes. I will start like this. I will say, consider this triangle, of course, has a description. You can see I have done the descriptions already so that we don't waste time doing that. Okay, so consider this part now, which is consider triangle ABM. Okay, if we consider this triangle, then we can say from this side that sine B, of course, the ratio of the opposite side to the hypotenuse side gives us the sine of the angle. Okay, so this will give us the opposite side facing this angle is AM. Opposite over hypotenuse. The hypotenuse there is AB. Okay, let me make this to be a fraction. See, this is also a fraction. All right, now this sine B is equals to AM over C. Now if I cross multiply cross multiplying, you realize that AM is equals to, this times this will give us little c sine capital B. Okay, I can call this equation 1. Then I'll come over here and I'll say from triangle ACM, okay, I will also say that sine this capital C, this angle here, sine C is equals to opposite over hypotenuse, which is AM, over hypotenuse, which is AC. Okay, all right, let me make this as well to be a fraction so that we have sine C equals to AM over B. Now, if I also do what I did before, cross multiply, I will have that AM is equals to B sine C. Call this equation 2. All right. Do you realize that AM is common to equation 1 and 2? Do you realize that? So we can equate them. So we can say since AM is common in 1 and 2, in equation 1 and 2, comma, equate them. So in equating them, we will have, here is it, we will have C sine capital B equals to B sine capital C. Okay, now permit me to do some manipulation. Is it manipulation? Not actually. Some change, a little change. Let me do a little change here. Permit me to rewrite this expression as, so if I rewrite this expression as B over sine B is equals to C over sine C. Let me explain. Look at this expression I have generated and cross multiply it. Do cross multiplication here. B times sine C. Did it give you B sine C? Okay. Yes to that. C times sine B. Did it give you B C sine B? So that is to say that this expression is equivalent to this. Look at it again. This times this will give you this. What? No. This times this will give you this. And then this times this will give you this. That is B times sine C is B sine C. And C times sine B will give you C sine B. So that is to say that this expression is equivalent to this expression. They are the same thing. Okay. All right. Now, we, having been able to generate this, can make a generalization. We can make a generalization. I can now say similarly, that is, if this holds, it then means in the same vein, something like this can also hold. All right. So I will say similarly, A over sine A will be equals to B over sine B. Okay. And if we look at this and this, okay, we can now combine them. We can say combining the expressions. We can have that A over sine of A is equals to B over sine B equals to C over sine C. Some mathematical work, some literature writes their own expressions like this. They are the same thing. They write as they write this as sine A over A equals to sine B over B equals to sine C over C. Both are correct. Whichever way you write it, either like this or like this, they are correct. Now, the most important thing is the application. So you can look at it from this derivation down, look at the logic that we followed and look at it down, down, down. Okay, you'll be able to see how we'll be able to generate the first expression down to the second expression, and then combining them, and then we're able to generate these expressions. Now this is what we call the sine rule. Application. You are going to see me use this sine rule to solve problem that has to do with triangles. In the next classes we are going to be doing, you are going to see me apply this. But for the purpose of the class, where you apply sine rule is in solving problems of triangles where two sides, especially, there may be other informations around that triangle. When we'll be doing this, you see it in practical application. So when you have two sides and one angle opposite the sides, that is to say, how can I be able to show you this now? How can I be able to show you this now? If you have if you have if you have something like this, let's assume, I'm sure you're taking note of this once I am cleaning. Just if you have something like this, and this is a triangle, and you have two sides, let's say here 10 meters, and here let's say 15 meters, and then you now see that maybe this angle here is given to be 82 degrees. Okay, 82 degrees. It is very, very possible with this now for you to find, let's say, this place being x, because you have this over sine this equals to no, the information here is not complete. Yes, maybe somewhere here, um 50 degrees, so that you can have this over, no, I think I have to put this angle around here, 50 degrees. Yeah, so I think it's okay now. So you can have this over sine this equals to x over sine 50. So with this now, you can be able to, with that information now, you can be able to calculate. So you have two sides and the angle opposite one of the sides. Two sides, basically. So I may not begin to elaborate on the angular the issues around triangles where we can. I think the best thing is when I start applying them, you also see, if you follow me in the next classes, you'll be able to see their application. But take note of the basic thing I said here. The basic thing I said here is that you must have two sides and the angle opposite one of the sides. Okay, when I derive cosine rule, you also see how the application goes. I think the explanation I gave here will be enough to guide you. Please like the video and share it to your friends, and please, if you subscribe, you'll be able to know the progress we are making, and you'll be able to be notified when we have made new uploads, and you'll be able to have access to the previous classes we have had. Thank you so much for being there.